This video introduces the concept of interventions and how we can model them in the context of causal graphs. Interventions are key to the idea of causation, and they are to be understood in contrast to the idea of passive observation. You can passively observe that someone has taken a homeopathic cure for the flu, and then measure their symptoms over the next week. Or you might intervene to make them take the homeopathic cure, whether they would have done so or not, and then measure their symptoms over the next week. Clearly, what you can infer about the world from passive observation is different than what you can infer from an active intervention. And that topic is rich and worth studying. Here, however, we only show how we can model interventions in the context of graphical causal models. Consider a simple causal graph in which the job performed by an individual is a common cause of income and health, and income is also a direct cause of health. Now consider an intervention on income and how we can model that in the context of this graph. There are several kinds of interventions we might model. Here we consider two: hard interventions and soft interventions. A hard intervention is one in which the intervention completely determines its target. In this case, suppose we flip a coin, and the result will completely determine income. Suppose, for example, that if the coin lands as heads, we assign income to equal $5,000 per month, and if it lands tails, we assign income to equal $10,000 per month. We can represent this by adding a new variable to the causal graph that represents the intervention, and then an edge from the intervention variable to its target. By completely determining income with this hard intervention, we have effectively eliminated the influence of the variable job. If our experiment is indeed as we describe it, then someone making minimum wage will have the same income as a CEO of a Fortune 500 company, provided the coin flips for them come out the same. So to model this, we eliminate any edges in the causal graph that pointed into the target in the original graph. This means that the target variable becomes independent of all its other causes, changing the original causal structure of the system. So this will be the new causal structure after we eliminate the edge from job into income. What about the edges coming out of income? In this case, the graph claims that income is a cause of health, presumably because higher income allows people to purchase healthier foods, to enlist better health care, etc. By taking over one's income, we presumably do not change the influence of income on health. We only change the value of income. And thus we leave the edges that in the original graph come out of the target. So this is the graph after a hard intervention on income. So let's consider again the original causal graph relating job, income, and health. And now let's consider a soft intervention on income and how to model it. Whereas a hard intervention takes over and determines the value of its target, a soft intervention adds a known and controllable source of influence, but doesn't eliminate the original sources of influence. For example, we might again flip a coin, but this time if it comes up heads, add $1,000 to monthly income, and if it comes up tails, add $2,000 to monthly income. As with hard interventions, the interventions can be represented as a new variable pointing to the target variable we are intervening upon. In contrast with hard interventions, however, a soft intervention does not eliminate the other direct causes of the target variable that were in the original or pre-intervention graph. So the final graph after the intervention will have all the original causal edges plus the effect of the intervention on the target variable. So to review, we model an intervention by adding a new variable outside the original graph and add a directed edge from that variable into the target of the intervention. If it's a hard intervention, then we eliminate all the edges from the original graph that point into the target. And if it's a soft intervention, we leave those edges intact. We always leave all the other edges, such as those coming out of the target of the intervention, intact. In this more complicated and abstract example, consider a causal graph involving x1, 2, 3, 4, 5, and 6. And now consider three simultaneous and independent interventions: a hard intervention on x1, a hard intervention on x4, and a soft intervention on x3. What is the post-intervention graph? The edges into the hard intervention targets will be eliminated, but every other edge will remain, leaving us with the following graph.